Alright, what we're going to do in this video is some acid naming. It is part of naming that can be a little bit confusing, so hopefully this video will help you. There's a few homework assignments that this is sprinkled in, but this is in your notes, naming acids, some rules for naming acids. And we know something is an acid. At this point, we know it's an acid just because its formula begins with an H. We'll have a whole unit on acids and bases later, but right now it's just something that starts with an H, and that's how we'll recognize it and need to name it as an acid. And there are two types of acids that we'll learn about: those that do not have oxygen and those that do have oxygen. And depending on if they have oxygen or don't have oxygen, we will use some different naming rules. But really the most important thing to understand about the naming is that you'll need to know the names of these, your ions, your anions. So you're going to need your ions list. So there's going to be three different types of names, really. So if it doesn't have oxygen, that means that you'll have H plus some anion. And if you look on your ions list, all of the anions that do not have oxygen all end in IDE. All right, so since they all end in IDE, when we name it as an acid, we'll take that IDE away. We'll add hydro and then have the root of the ion name, ic acid. So the example here is HCl. So ignore the H, that just tells you it's an acid, but Cl, the name of that ion, chloride, is Cl minus, so it ends in IDE. And so to name it as an acid with the H, we would say hydro, and then the root here is chloric acid, right? So that's one. The two that have oxygen, remember the two ways that the anion name could end is either with ate or ite. So for example, like sulfite and sulfate. So if it ends in ite, like nitrite, we would take the root and then add us acid. So again, we cover the H, we recognize the nitrite formula, and then we would name the acid that contains nitrite as nitrous acid. If it were an ate ion, like sulfate, we could cover the H and recognize this as sulfate. So when we need to name the acid of sulfate, we would change it to ic acid, so sulfuric acid. There are some really cheesy and dumb ways to remember these. I've heard this one is Sprite is delicious, and this one I ate something icky, and the best one, I think, my ride has hydraulics. So I don't know if those will help you, but they're so terrible that maybe you will remember them. So we're going to practice naming some acids using these rules, and we're going to go both ways, from the name to the formula and the formula to the name. They're both kind of tricky. So we'll start with this one, acetic acid. And the thing to recognize here, it is an acid, and this particular name ends in ic acid. All right, so once you recognize that, if you look back at the rules, the ones that ended in ic acid, it came from the ion that ended in ATE. All right, so if you look at this, you need to find the ion for acetate. If it ended in ic acid, that means it came from acetate. So then you look on your ions list, you find acetate, there it is. So acetate has the formula C2H3O2 minus. So this is not the answer, but I'm going to write it to help me get the answer. I'm going to copy this formula, C2H3O2 minus. All right, that's the formula for the acetate ion. And what you need to do to make it into an acid, to write the formula for acetic acid, is you need to add H pluses. That's what makes it an acid. Add H pluses to balance the charge. So since this has a charge of -1, I just need one H plus to add to this formula. And we'll always just add it to the beginning. All right, so this ion, if we want to turn it into an acid, I need to add a single H plus to cancel out that -1 charge. So the formula for acetic acid will be H, and then this formula, C2H3O2. So this was just acetate. This is the formula for now acetic acid because it has the H in front. Okay. All right, so the next one we're going backwards. We get H2CO3. So when you were given the formula, cover up the H and look at what's left over. CO3. That's going to be an ion on your anions list. So if you look for CO3, look for it on your ions list, it's right here, CO3 2-. And that makes sense because it has a -2 charge. That means you needed 2 hydrogens to balance the charge. So this is from the carbonate ion, okay? So carbonate, so it ends in ATE. So then we'll look here, it ends in ATE. So to name it as an acid then, we need to take the root and then add ic acid. Okay, so the root for carbonate is carbon. So instead of carbonate, it's going to turn into carbonic acid. So that would be the answer here. There's the root, ic acid. Okay, so this came from carbonate. CO3 2- is carbonate. So feel free to write little notes to yourself like this on the side when you're working through these problems. Okay, so it ends in ATE, and that's going to help you figure out how to name the acid. This is carbonic acid. All right, so next one, same thing. HClO3, we're given the formula. So we can cover up the H and find ClO3 on our ions list. ClO3 is right here. Chlorate. Okay, so this came from ClO3-, chlorate. So again, it ends in 8. So it's actually going to follow the same rules as the one we just did. It ends in 8. So we need to change it to the root ic acid. So the root here is chlor. So we'll just have chlor, and then we turn it into ic acid. So it's chloric. Chloric acid, HClO3. All right, now we have a similar one, chlorous acid. Kind of similar name. But notice this one ends in us acid. So if we go to our rules, if it ends in us acid, that means it came from ite, the anion that ends in ite. So that means that this came from chlorite. So let's find chlorite. Here it is. ClO2- is chlorite. So I'm going to use that formula to figure out what the acid formula will be then. Remember, to do the acid formula, you need to add H pluses to balance the charge. So since this has a charge of -1, I need to add 1 H plus in front of the formula to balance it. So this is going to be HClO2. This is the formula for chlorous acid, right? Similar to chloric acid, different number of oxygens. All right, next, hydrobromic acid. So this one has hydroic acid. So if you look on our rules, hydroic acid came from the ion that ends in IDE. So this one will not have oxygen. We're just looking for the IDE of brome. So bromide. We're looking for the bromide ion. All right, so bromide's right here, Br-. Okay, so Br- is bromide. So now all we need to do is add H pluses to balance the charge of -1. So again, we just need 1 H here. So it's going to be HBr. And remember, since it had the word hydro, we don't have any oxygens here, and that makes sense because there weren't any oxygens in the anion. All right, so that is hydrobromic acid. And then the last one, HCN. So cover up the H, CN. That's the anion we need to find. CN, there it is, cyanide, ends in IDE. Okay, so we have CN minus is cyanide, ends in IDE. So we need to use our IDE rule. So it's going to be hydro something-ic acid. Hydrocyanic acid, because that's the root. Okay, so it's hydrocyanic acid. Sounds scary. Probably is. All right, so those are your acid naming rules and some examples, both names to formulas and formulas to names. Both ways are a little bit tricky, so you need to make sure you can do both of those. All right, let me know if you have questions.